Okay. You just want to go there. That's wrong. No. All right. So, okay, we're going to talk about angle relationships today. There's a lot of new vocab. I'm going to review some old stuff, plus talk about your homework problems in a little bit. Quite a few things. I know that some of the text up here will be a little small. I'll zoom in on it in case you need to see it. I'll kind of do that with the PowerPoint. I didn't realize how small it was until I actually show it, like on a projector, and then it shows kind of how small it can get. All right, here's our outline. Okay, we're going to do a quick review. Let me zoom in on that because it's pretty small. Okay, all right. We're going to talk about adjacent angles. It's up here if you can't see it. But adjacent angles, we're going to talk about perpendicular one more time. These are things we've already discussed. I want to talk about the parts of angles. That's a part of that. Everyone knows the angles and how to name them and stuff. But the parts of an angles will help us when we get to these. There's a certain vocab word we need to talk about adjacent. That's why I'm just going to talk about parts. Then new vocab terms today. We're going to talk about linear pair. That's something that I hinted at the other day, but we never got to it. We'll talk about vertical. That's probably we will end right there today. We'll do that example. We'll talk about something in real world that you can use to see that. But then like the two other vocab words I had on the slide, we'll probably see tomorrow. We're going to see complementary and supplementary. These two words in particular are something that a lot of people get wrong. Like a lot of people get it wrong because they mix the two together. So that we're going to save that for tomorrow, so I'm not kind of rushing to get it done. But yeah, we have only select few words. 2 old words and then 2 new words. That's what we're going to kind of do today. Homework. That's due tomorrow. Remember, I had a lot of people already asked that. We have homework due tomorrow. That's at page 41. I have it on the board over there. You can see it. It's due tomorrow. Keep that in mind. You'll want to work on it. I can tell you right now that the most challenging problems on the assignment are number 9 and 10. 9 and 10, right off the bat, those two are probably the most challenging problems of the whole assignment. It's what they give you and how you're supposed to look at it. I'll put a picture up on the board today and kind of walk you through what I'm discussing. Okay? All right. Adjacent. We already have this word, but if you want to write it down again, that's good practice. Here we go. It is 2 angles that lie in the same plane. They have a common vertex and a common side. I'll let you write that down. And there's a little extra piece that we haven't discussed yet that we need to talk about. So 2 angles that lie in the same plane, same flat surface. They have a common vertex and a common side. We have a bunch of pictures here. I think I have, for this one, I have 4 or 5 pictures we're going to go through with this, just to make sure that you can see it. We'll zoom in on it and everything. Alright, 2 angles that lie on the same plane have a common vertex and common side. Now, the new stipulation, this is something we've never discussed before. The book says this. This is one extra bullet. I put a little asterisk next to it. We need to highlight this. This is one of the parts we need to discuss. They can share no interior colors. You guys just sneeze at the same time? You just,
No, I thought he was going to sneeze on me.
Alright. That was weird. Doing it out there. Alright. No interior points are shared. Here's the picture I want to talk about. Okay. No interior points are shared between the two. If you're looking at this picture, I'm going to zoom. Does anyone need the word still? I'm going to zoom in on the picture just so you can see this. Ooh. Here we go. Alright, on this picture, these 2 angles are side by side. They're adjacent. They share a vertex. They share a common wall in the middle. This is perfect. You have angle 1, angle 2. They obviously look at different sizes. Notice the bubbles I used, the little arcs. If angles are different in size, they'll put those in there, typically. If they're equal, you'll see this. That's brand new. So if you have equal congruent angles that have the same measure, they're going to put little bubbles. The bubbles do not have to look perfectly the same like mine don't. They're not even level with each other. That's fine. These are equal. Most people want to see it look like this. They want to see like the bubble continues. It doesn't have to be. Now, how this could happen, like how could you have 2 angles that are side by side that could be equal, like they're adjacent but they're equal. Your book has that for number 9 and 10. What it says in the book is that, let's give this a name, let's call this B and D. That ray, angle B, or sorry, ray BD, that ray can bisect your angle. Maybe this angle is ABC. So sorry, you're already annoying me. All right, so ABC. It's going to bisect that angle. What that means on number 9 and 10, that these angles are exactly equal to each other because this went right through the middle. The picture could look terrible, like that looks really bad. But if they say that in the instructions, those two angles are identical, whatever it is. So if they say this is a 7x plus 2, this other one's a 7x plus 2. You can just transfer it over automatically. You need to be aware of that. Number 9 and 10 say that. Okay? It's one of those things I think they throw it out, and we've talked about the word bisect, it goes right through the middle, but I don't think everyone's ever put it into practice. It means you have it and copy it twice. All right, now.
Juan Carranza, please come to the office. Juan Carranza, please come to the office.
All right, now, the other picture that the book has was this one. Let me scroll down. Come on. There you go. These angles are still adjacent. They're still side by side, 1 and 2. They're not equal. One's obtuse and one's acute. But the idea is that they are side by side. They share the same vertex. They share the same wall in the middle. Even though we're past 1/8, we're in that reflex mode, that reflex stage. It doesn't matter. You can still have two angles that are adjacent to each other. They're not sharing any points in the interiors, and I'll explain that with the next picture. But you just need to see different pictures that can apply to adjacent. Now, next picture. This is the one we need to discuss. This one in particular. It looks like all the others. Nope. All right. How can we just zoom out? Guess not. Okay, well, we'll just not let me see that. Okay, whatever. That angle over there, if you can't see it, it's supposed to be like this. They have this one in the middle. They say this is angle number 3. This is an A, B, and C. Now, it looks like the last picture. Like, oh, well, these are adjacent, right? These two angles, yeah. If there's like, let's say this is angle number 5. 5 and 3, yeah, they're adjacent. They're side by side. They share the wall in the middle. They share the same vertex. But what the book talks about, they compare. They compare angle ABC to angle number 3. 3 small, ABC is huge. And in fact, they overlap each other. This is ABC, it's the whole angle. 3 is right here. You see that they overlap? Those are not adjacent. They're overlapping angles that cannot be adjacent. I know they share the same vertex, they share the same wall, they share the bottom wall, BC. But it failed this point, that's why I made this an asterisk, that you can share no points in the interior. If I pick a point out here, let's call this point P, that's in the middle of angle 3, that's an interior point, that's the interior of the angle. It's also the interior of angle ABC. So if they're actually comparing these two, they're not adjacent. So just be careful. The reason I'm bringing this problem up, why I showed you this picture, this is what number 9 is telling you. Number 9 is giving you angle number 3. They say angle number 3 is a 7x. So this angle is a 7x plus 2, or something like that. And then they give you the big angle, which is like a 9x plus 1. They overlap each other. Are those two angles equal to each other? No. I have people trying to set them equal today. I don't know why. They don't even look the same. One's small, one's big. You need to read the instructions because the instructions said that this wall right here is actually a bisector. Well, if that's a bisector going through the middle, then that means the 7x plus 2 can be transferred over. These two little angles are equal to each other because that went right through the middle of them. And now you can add these two to make that big thing. Add the small ones to make the big angle. Be careful of that. That's number 9. No joke. That's how you're supposed to do it. Some people are really getting confused on that. They're refusing to draw it. They're refusing to use common sense to look at it. Okay, questions at all about number 9? All right, let's move on. I think I have one more picture that's going to appear here. Let's see, I gotta zoom all the way up. Oh, weird. All right. The last picture. Man, I wish I could zoom in on that. Why isn't it wanting to? I think I switched the aspect. Aha! That's why. Switch the aspect ratio. Aha! That makes sense now. I couldn't do it. All right. Yeah. Okay. The reason I'm bringing this hot mess up, this thing, there's a bunch of angles in there that are adjacent, that are side by side. There's a couple that are not. So this is a good one to like practice the vocab on. Angle 3, that's this angle here, and this angle right here. Are they adjacent to each other? Yes, they should have. Dot, they have a wall going up between them. They are side by side, they're adjacent. What about angle 3 and this angle? No, definitely not. They're apart. They're not even sharing the same vertex. They are sharing kind of a wall, but it's not the common wall between them. What about that, this angle right here, and this one? Yes, those two are adjacent. You guys get the idea. The reason I'm bringing this up and why I'm such a stickler on these angles, if they're adjacent, you can add them and make bigger things. You can add two small ones to make the big angle, or they make a straight line, that type of thing. So just be careful of that. I just want to make sure that you're kind of aware. All right. Questions at all about the vocab here, especially on this problem? This is pretty new. All right. Perfect. Let's move on to the next one. Perpendicular. You already have this word as well. This should be a review word. The definition of perpendicular. It's a line, ray, or segment that forms right angles. Now notice, it says it has to be a type of line for it to be perpendicular. Now if you go back to the definition of what I talked about right angles, this one, I introduced this word earlier this week when we talked about right angles. You know, there's like 4 words: perpendicular, orthogonal, flush, square, whatever you want to call it. There's a difference between perpendicular and the word orthogonal. They still give you 90s, don't get me wrong. But why you choose one word or the other over the other? Some people are like really thrown off that there's like 4 words you could use. Perpendicular is when you're talking about lines that meet at 90s. What's the symbol they use for a right angle if 2 lines meet? A little square, that little pink square in the corner. There you go. That little thing. That's 90. I'll zoom in on that here in a second. But if they use the word orthogonal, it's because they're comparing geometric figures together. Like let's say I have a triangle and it's touching a square, and there just happens to be like a 90-degree angle between the 2 pictures. Like where they met, it made like a perfect 90 somehow. That's called orthogonal. The objects are orthogonal to each other. They're 90 degrees, they're flush, they're perpendicular. But the idea is that when they use the word perpendicular, they're actually talking about the lines. It's the same thing. It's just being, petty about which word you use. So, perpendicular, this is the symbol. In fact, I'm going to zoom in on it. Hopefully that'll zoom right there. Oh yeah, look at that. Okay, so they're going to use that little pink box. The big thing about this is just getting comfortable with, what you're going to be looking at. There's 4 stipulations for things to be perpendicular to each other. Other than just making a right angle, like there's things that will happen on this picture. We're going to talk about that tomorrow, the 4 stipulations. The reason why I'm going to talk about it tomorrow, we need the other vocab words to make sense of it. To make sense, like, what are they talking about when they have 4 stipulations being perpendicular. The book puts this word, like, last. In fact, I wasn't even supposed to talk about this word for, like, a couple days ago. I was supposed to save it until after this chapter, after this section. But it's nice to know it, that you can have things that meet at right angles. Instead of calling it right, you know what it's called. But we need to get through those stipulations tomorrow. It's a Friday kind of topic. All right, questions on the drawing? Perfect. And by the way, if they don't have the box, that little pink square, or they don't tell you that it's right angle or perpendicular from the directions, it's not right. You can't assume it. It might be 89 degrees, not 90. So just be careful of that. All right, Let's move on. Oh, huge. You need to write the symbol down in your notes right now. This symbol right here is the symbol they use for perpendicular. It's an upside down T. T intersections make 90 degrees. So T intersection is going to be perpendicular. So AD is the line AD, that's how you pronounce it. Line AD is perpendicular to line BC. That's how you say it out loud. The reason why we have to bring this up, your book, and by the way, all these pictures are directly out of your book on the next section. You're going to start to see that upside down T everywhere in the book. Like they're going to use it way too much, like all the time. So you just need to get used to that. It's talking about 90 degrees. And you got to go figure out which angle is 90 by looking at that picture. And that'll be a part of the 4-step stipulation we're going to talk about tomorrow. Okay. Are we good with vocabs up to this point? Those are all review words, adjacent and perpendicular. We talked about those earlier this week. New word, linear pair. Definition of it. It is a pair of pair of adjacent angles, but the non-common sides are opposite rays. And that's a lot. That's a lot to take in, lots of vocabulary. Pair of adjacent angles, so they have to be side-by-side angles, where the non-common sides are opposite rays. That's vocab. I thought PowerPoint would be a lot easier today for vocab. And again, I always put the PowerPoint slides online, so you'll be able to see those later too, in case you're scrambling and clicking through too fast. All right, now adjacent angles. They have to be angles side by side. Here's my example. Angles 1 and 2, do you agree that they're adjacent? Side by side. Okay, we've done these. To make it a linear pair, the walls that are not in the middle of them, so the wall that's, I don't care about the wall that they're sharing, I'm talking about the walls on the outsides. If the walls on the outsides form an opposite ray, you have a linear pair. What does it mean to be an opposite ray? What type of angle do you have? 180. You've already been doing this word, you just didn't know the vocab. In fact, I actually hinted at it yesterday, I think I said it out loud. When you have a linear pair, they're making a straight line. You're allowed to add these angles together to make 180. Well, if you think about that, we already did that. That's part of the homework. You added angles together, angle addition, and it makes 180 sometimes. But this is called a linear pair. There's a difference between this word and the word collinear. And I want to just bring this up. This is a part of angles we need to discuss. Collinear is when points are on the same line. Points on the same line versus two rays are opposites and they're adjacent, right? So I could have on this picture, I could have ABC being collinear, and you could have a linear pair of angles. The angles are a linear pair. You're gonna have to do that a lot in the homework. That page, 41 has a bunch of stuff where you're adding angles to make 180, you're adding angles or setting angles equal to each other because of the bisector idea. So just be careful. You'll have to kind of draw the pictures and label stuff so you can kind of figure out what you need to do. It's not every time, you're not always adding every single thing to make 180. Sometimes they don't give you enough information to do that. So you got to figure out which two angles are equal to each other. But those are your basic vocab terms. That's new, but I think I used that word yesterday and I just said we're going to talk about it tomorrow. So. All right. Now, that picture over here, the second picture I'm giving you, this is a mess. Is that a linear pair? No. At no point do any of the angles make straight lines. So like, you can see it, there's a bend in the road. So like, if I were to add this angle together and this angle, I'm not getting 180. This thing had a flex. It went past. We're in the realm of now reflex angles. You're getting way too big. It doesn't matter which pair you pick. They're not making straight lines across like this one did. Now, there is a symbol for how you know is it making a straight line. There's a symbol. And the book sometimes does it, sometimes it just says opposite radius like I warned you yesterday. But if they're going to warn you, like this thing is going to make 180, this is what it will do. They'll put a little bubble on it, and that signifies that you have 180 degrees all the way across. Okay, so just be aware of that. It's not saying that the two angles are equal, because they're obviously not. That one's huge, that one's small. But they do make a form of a straight line. Sometimes that bubble does help. But look for the words opposite rays in the directions. Questions, comments about that word? Okay, last word today. Anyone still need that though? Perfect. Last word of the day. Vertical angles. So last word, once we go through our example, we're done. You can work on your homework for the rest of the time. You have about 15, 20 minutes. Vertical angles, by definition, they are two non-adjacent, that means two angles that are not next to each other, non-adjacent angles that are formed by the intersection of two lines. Now, the reason why I bring this up is when you see the picture, it gets confusing with the last one we just did. Linear pair, you know, like, Ward, you just showed me the same picture. There's a difference. So, two non-adjacent angles, angles that are not next to each other. Linear pairs had to be next to each other. Vertical are not next to each other, and they're formed by the intersection of two lines. Once you have these all written down, we'll give the examples. I have a couple pictures I picked out. Looks like everyone's kind of got it written down. All right, here's the picture. Now, you're thinking, Ward, that looks like the same picture you just showed me earlier. It looks like a lot of linear pairs. I agree. There's some angles that are side by side that are form a linear pair, like angles 1 and 4. That's a linear pair. They add to make 180. 1 and 3 add to make 180. 2 and 3. You get the idea, right? But vertical are the ones that are not next to each other. So can somebody give me two numbers up there that are not next to each other? Right, give me one.
1 and 2.
Say it again?
1 and 2.
1 and 2. Those are vertical. They're vertical angles. They're the ones across from each other. They are vertical from each other. Also, 3 and 4. Those are vertical. Now, you're thinking, okay, Ward, what's the point? Why are you showing me that? The first property you're going to learn right now, vertical angles are equal. Vertical angles are equal. Maybe you want to write that down. Vertical angles are congruent. Or equal. It's the first property in math you're going to be learning here. So, in fact, on this picture, I actually have it already marked. 3 and 4, I put little bubbles on those. Those are equal angles. I want to prove the point. I want to talk about why that works every single time. It's common sense once you see it, but you do need to see why they're always going to work no matter the pair. As long as you have straight lines crossing, there have to be two lines that intersect. So to prove that 3 and 4 are the same angle, I need somebody to give me a random number between 90 and 180.
91.
91, okay. So 90, so let's say this is 91 degrees. Okay? I'm going to prove that angle 3 and angle 4 are the same number. Okay? So, in fact, let me zoom in on this. I'm going to have to move the 91 here in a second. Alright. 91's going here. Alright. To prove that 3 and 4 are the same number, what do these two angles add up to be? 180. That's a straight line, right? We said there are two straight lines crossing each other. So, whatever angle 3 is, whatever the measure of angle 3 is, it's going to add with 91 to make 180. So I can subtract the 91 over, I get 89 degrees. Okay, that's angle 3. Angle 3 is 89. Well, same exact idea. Angle 4 has to add with 91 to make 180. This also forms 180. So angle 4, the measure of it, plus 91 makes 180 as well, because those were straight lines. Well, you get the idea. I subtract the 91 over, and boom, we get 89. They're the same number every single time. So what I want you to know is the angles that are across from each other, 3 and 4, those are equal. 1 and 2, those are equal. So angle 2 is also 91. So if I gave you a picture like this where you know they're straight lines, and it's told you that, maybe this says line this intersects line this, you can transfer numbers across the picture really quick. Now, there is this object that I want to talk about that you can get at Hobby Lobby. I know it seems a little funny. That is a toy that I remember playing with as a kid. It's not really a toy, but it's this thing I remember having as a kid where you can see vertical angles. And I know it seems a little goofy that it has something like that, but it was something you could buy in the store. It kind of looked cool. And I don't know where I saw it. I saw it on TV, I think. All right. So what the toy was, it's this little plastic piece you buy at Hobby Lobby. It's about 2 inches long, a little plastic cylinder. It's hollow, it's just a little plastic thing. And what you can do is you can attach pop bottles to it. So you can like screw a pop bottle on the top and the bottom of it. So one of the bottles will go here, there's a pop bottle, and one of the bottles will go here, okay? And what you do is you put water in one of the bottles. So let's say you filled one of the bottles on the bottom, you filled it with water. And you attach the top bottle on top, and that's empty. And what you do is you take the bottle, so now that little ring is in the inside, right? You turn the bottle over, so now the water's on the top. And what you do is you spin it, right? You just spin it right at the top. Gravity's gonna do the rest. Gravity will start pulling the water down, and what will happen is it'll make a cyclone, and it'll start emptying water through the little spigot thing, and it'll go into the bottle down below, okay? And you're thinking, okay, why is that a toy? Because what happens, you're gonna see a tornado. It's like a perfect tornado. It'll be doing its thing, draining the water out. But on the bottom bottle, the tornado's upside down. It's a perfect reflection. The tornado is an upside down tornado. And it'll start spitting the water down here like that. And the water will be coming out the other side in the same form. The reason why, it's a vertical angle. If you can see it, it's literally just doing this through the pop bottle where the water's going in and out the same way. The angles are the same. So yeah, the images will be mirror images of each other. That's all it is. It's a fancy little toy you can buy for like $1 or something like that. I'll try to get one. But, all right. Questions at all about vertical? Okay, homework today. All right, guys, homework that's due tomorrow, I should say. All this. Boom. Yeah. Boom. All right, it's due tomorrow. That's your page 41. Make sure you're working on it. Watch out for number 9 and 10. I warned you of that today about the bisector idea. No, I'm gonna talk to him today and see, because I think what they're doing is they're adding all the names to the registry, and then tomorrow I'm gonna have everyone log in and see what we do. So I've given them enough time. They should have all their ducks in a row.